Okay, today I'm going to be showing you how to make rope out of liquid. So what's cool about this is because it's taking a liquid and turning it into a solid polymer, it looks a lot like spiderweb. And so what I want to do is see if I can actually make a realistic spiderweb out of it, because I have a hunch that this is what the real Spider-Man uses to make his spiderwebs. Depending on what Spider-Man you've seen, he usually has some kind of liquid that he sticks in there and he pushes a little button and it shoots out, and it's this kind of long polymer string from these liquids. So I have here two special liquids. This one is called 1,6-hexane diamine, and this one's called sebacoyl chloride. And what's special about these is, apart, they're just a liquid, but when you touch them together, the molecules from each of them combine together to start forming a chain. And what's cool about this chain is one molecule of this doesn't just react with one molecule of that and stop. What happens is one from this comes with one from that and connects, and then one from this one connects on the other end, then one from this one connects on the other end, and it just keeps going and going and going and forming a long polymer. And with this specific solution, it's going to form nylon. Okay, so first I'm going to pour in the hexane diamine. Now I'm going to pour in the sebacoyl chloride, and the goal is that you don't want to mix them. You want there to be two separate layers of the liquids, and at the interface is where the polymer will form. So you can see now that there's two separate layers of liquid, and then there's this white layer in between. And that's what I want to grab and pull up with my tweezers. Okay, here we go. Whoa! Look at that. It just keeps coming. That's so cool. Okay, you can see that seemingly out of nothing, this rope starts to form. Just grab it. There it is. And just keep pulling it. That's so cool. Okay, here we go. I'm gonna try to form my spiderweb now. Start it right there. See how it just keeps coming? Okay, so there's my finished product. Let's see if it works. Strong like a spider web. Let's see how strong it is. So if I were really ambitious, what I could do is take these little strands and then I'd weave them together and I could make a strong nylon rope with this. So the question is, would it be realistic for Spider-Man to use a polymer like this? So you see that to make this amount, this made about 15 feet of rope, and I needed 2 bottles about this size of the initial chemicals. So let's say Spider-Man were to be able to make some type of device that kept the liquids from mixing and just allowed the interface to mix, so that when he pushed a button, it forced out that interface and it pulled the polymer along with it. Then you could say, okay, that could be realistic that he could shoot nylon out of his arm like that. But the hard part to believe is the volume of it. So for Spider-Man, you see, usually they're little cartridges that he uses, and it produces a large amount of webs. So I can't imagine how he could use a chemical that's so small in liquid size that produces so much polymer. But hey, I'm not Peter Parker, so I don't know. Oh yeah, and I forgot to mention another little hurdle for Spider-Man. The reason I'm outside doing this is because these chemicals are toxic, so even after they're not reacted fully, and you're supposed to rinse them off before you touch them, so he wouldn't want to touch his own web with his bare hands afterwards, if he was using this method. Okay, so the nylon that I made here is called nylon 610. That's just saying how many carbons were on the initial molecules of the reactants. So the industrial nylon is nylon 66, and it's not quite made this way, but the reaction is the same. Hey everyone, thanks for watching again. I hope you liked it. If you have any questions or comments, let me know in the comments section. And if you're not subscribed yet, hit that subscribe button and hit the bell to be notified when my latest video comes out. And I'll see you next time.